Hey there everyone, all the techies and data enthusiasts there. So guys, welcome you all to my YouTube channel. In this particular video, we are going to discuss about how can we fine tune Llama 3.1 8B model using Unsloth. So those who all don't know about what is Unsloth, Unsloth is a fast attention mechanism model which can fine tune your LLM models 30x faster compared to other models or other training methods. So here using Unsloth today we are going to fine tune and we are going to see why is it that fast and how is it different from the other fine tune traditional method fine tunings. So guys, this video is definitely going to be very interesting. If you have not subscribed the channel, do subscribe the channel and on the bell notification. If you have not followed me on LinkedIn, do follow me on LinkedIn. Now let's get started. So guys, this is the main Unsloth introduction page. You can see here introducing Unsloth 30x faster Llama training model, LLM training model. So they claims that the memory usage and even the way you're going to work, it's going to be very fast compared to other things, and it's free and open source as well. And even you can see here they are telling you can even fine tune the model in Google Colab itself. Today we are also going to fine tune the Llama 3.1 8B model using Colab only. And they are also claiming that you can even use Alpaca datasets and SimOrca, and you have any other Kaggle notebooks on Leon datasets. So it's going to be very interesting. So you can just check out about what is Unsloth and how is it different and helpful. So it was invented by Daniel Han. So the same notebook we are going to use today. So this is Unsloth's GitHub repo. Here you have different free notebook examples for Llama 3.18b and Pi 3.5, Gemma 2, Mistral, Olama also you can use if you want to use. So it's going to be very interesting. Check out this as well. They have different blogs and benchmarkings, and actually it's a very good usage, you can say. You can just have a look on it, and even you have Unsloth Pro and open source as well. So have a look on this, and there you have the performance benchmarking. See, for Alpaca dataset, if it is Hugging Face is taking 1x, so fast attention model is 1.04x, but Unsloth is taking 1.98x, so almost 2x faster using Unsloth open source. But Unsloth Pro is giving 16x faster almost. So if we round figure this. For Llama 2 7B model, so you can see here the same benchmarkings are there. You can read this, it's going to be very interesting. And now let's dive into the notebook and discuss more about this. So first, before we start, make sure to change the runtime here. Go here and change the runtime type from CPU to T4 GPU. Okay. So for faster training. Okay. Now let's connect. Okay, so it's telling you currently cannot use due to usage limit. Okay, so let me just open this in another account. Okay, so I have just enabled it with my pro version account. So here now you can connect this to T4 GPU. Okay, so by default, some of them will get T4 and some of them, if they don't have, make sure to change it to T4 GPU and connect it. You can see here there are some Unsloth logo, and there if you want to give them or donate them some money you can, and you can join their Discord server as well. And you have here how to data preparation, train and run model and save it. In example, you can save it as Llama CPP model, or how you can do it, it's mentioned here. So we have connected. Now let us first install Unsloth. So Unsloth, we are installing it using Unsloth GitHub itself, and X transformers and TRL and PEF and accelerate. So this particular you can see here, you will get this, but you can just directly continue further. So it's getting installed. We need to wait for it to get installed, and it's running over, however, T4 GPU only. Okay, by the time this gets installed, let us see. So first we are importing from Unsloth package. We are importing fast language model and torch, and max SQL length is 2048. So it auto supports for rope scaling internally. So rope scaling, those who all don't know can refer it. It's a technique, okay, to scale the model. and data type and load in 4 bits. We are enabling it as true. So the model, so that quantization to reduce the memory usage. If you want, you can give it false, but if the model is quantized, then the memory usage will be less. So for that, we are enabling it as true. 4-bit model. So what all are the models they are having? So you can see here Unsloth models. All the models are mentioned here. You have Pi 3, Mistral, Meta's Llama 3.1, 405B as well, and Gemma, and you have many more. You can refer in their Hugging Face website. So this is Unsloth's Hugging Face website, where you have different models. You can see here. So you can just open that and use it. So this is their model free notebooks. This is an organization card. So models are here. Unsloth Pi 3.5. I can open this and use the model. So immediately I get it with transformers. So you got the transformers library here. You can use this method, or you can directly use the Unsloth package as well. Anything of your choice. For everything, they have given a greater examples. You can actually refer them. Yeah, I hope that's installed. So all the packages have been installed. Now let us load this. Okay, so those all are the available models from which we are taking the model and tokenizer. The model name is Unsloth. So this is our Unsloth model, and we are running this. So let me run this. Max sequence which we have defined up, the same thing we are taking, and the data types, and load in 4-bit. We are mentioning it as 4-bit, so that's what we are taking here. So will patch your computer to enable 2x faster free fine tuning. You can see here. So GPU, it is showing here we are using Tesla T4 GPU. Maximum memory is 14 GB, 14.748. You can think approximately 15 GB. And performance, you can see here it's Linux and PyTorch. Okay, so it's been downloaded. So while downloading, it takes some time. You can see here model safe tensor has been downloaded, which is 5.70 GB. So it's approximately 6 GB. So let this to complete to download. Okay, so we have downloaded all of them, and you can see here. So Hugging Face tokenizer catches here, and you can refer them actually. And you have sample data sets, which is California housing data set, MLS data sets, and even some JSON dataset is there. So we are going to actually use this dataset only to fine tune the model. Okay. Model is equals to fast language model dot get peft method. So those who all don't know what is peft, peft is nothing but parameters efficient fine tuning. So you have to like read about this blogs, then you will get it about in detail. And R we have defined as 16. You can define anything which is greater than 0. That can be 8, 16, 32, 64, or 128. Anything of your choice. And target module, you have Q project, K project, V project, and O project. So these all are there. We have to define them. And LoRa alpha we have called it. So those who all don't know what is LoRa, LoRa is low rank adaptation technique. Okay, so 16 and dropout as 0. So we are giving dropout as 0. And bias none. Gradient checkpointing, you can either give it true, or you can even write Unsloth in double quotes. So they have written it as double quotes Unsloth only. Random state is equals to 3407, and use RS LoRa. So what is RS LoRa? Rank stabilized LoRa, low rank adaptation technique. And you have loft Q. So let us run this. When you run this, you get the same result. Unsloth 24.8 patch 32 layers with 32 QKV layers and 32 O layers and 32 MLP layers. MLP are nothing but multi-layer perceptrons. So data preparation, you can see we are using the Llama 3.1 format for conversation style fine tuning. We use Maxim login fine tune 100x data set. So this is the data set. You can just open this data set. So yeah, redirect. So this is the dataset which we are going to use. So in which you have conversation and source from where it is. Okay. Dataset is share GPT style, but the conversation, but we converted it to Hugging Face normal multi-turn format. So they have converted it. Role is content, and instead of from value, Llama 3 renders multi-turn conversation. Okay, so these are the methods: begin, start header ID, user, and user header ID. So this is the format actually. You can have a look on it. Get chat template. We use the get chat template. We support it for, so this is supported for Zapier and ChatML, Mistral, Llama, Alpaca, and even Llama 3 and Pi 3. So let me run this. So the dataset we are calling here, you can see here clearly. From Unsloth dot chat template, import get chat template. Tokenizer is equals to get chat tokenizer, and we are calling the model as Llama 3.1. Formatting prompt function example, and canvas is equals to example conversations. Okay, text we have tokenizer dot apply chat ml convo, and tokenizer is equals to false, add generation prompt is equals to false. For convo, in convo written texts. Okay, pass and the dataset we are loading. From dataset import load dataset, and from load dataset we are loading Melbourne find tom 100k and split to train. Let's, okay, this has been already run. You can see I downloaded the readme, downloaded the data, and train split has been done. So you can see here. Okay, so now let's move further with, from Unsloth.chat templates import standardize share GPT. Dataset is equals to standardize share GPT dataset.map formatting prompt function, and batched is equals to true. So let's load this. These are different loading techniques. We are just loading for the dataset mapping. Let me just close this for now. Yeah. Now dataset 5. So from dataset 5, we are calling conversations. So wherever conversations is there, look for conversations or structure for item 5. So you can see here, how do astronomers determine the original wavelength of the light emitted in the celestial body? So it's a kind of content and their answers, you can say, user answer and the content. So we are just testing here what are the texts and what are the conversations there. So this is a text, you can see here, begin, start header ID, system, and end header ID slash and cutting edge data, and November 2023 date and everything. So it's a kind of the format which we have defined previously. Training the model. Now let's use Hugging Face TRL SFT trainer. So about TRL SFT trainer, you can just open this docs. We do 60 steps speed training. So this is a 60 steps speed training. If you want, you can reduce this maximum 60 steps to somewhere around, I'll make it to 30 off, because I don't want to, what do we say, give more time on this. So it will take more time to train. Compared to Hugging Face and other models, it will be fast, but here approximately it will take 2 to 3 minutes to train. So from 60 steps, I reduced it. SFT trainer is nothing but supervised fine tuning trainer. So supervised fine tuning trainer is crucial step for RLHF, which is nothing but reinforcement learning, and the TRL for API. So you can just have a look on this. It's very detailed written here. So this code link, right, you will be getting down below in the description in my GitHub. You can just go and have a refer on it. So let me just run this. Okay. Number of pro. So it will take some time here again. So we also used Unsloth's train on completion method to only train on the assist output and ignore the loss of the output. So train on only response. This board should be loaded, so it takes time here, and you can see how much the GPU it's going on. So right now the GPU it's already used 6.1 GB is been used. Okay, so you guys cannot see it there. But take it up. Yeah, now you can see it. See, it's scaling up a bit slowly. So let's wait for it to complete. You can refresh this as well, so that you will see some reflections. Even let me run this as well, so by the time both does, so I can explain better. So here what the trainer is doing, we are taking the supervised fine tuning method or trainer method. Model is equals to model, tokenizer is equals to tokenizer which we previously defined, and dataset which we loaded, right? The same dataset we are giving for training dataset. Fields is equals to text. Max equivalent we already defined it, like somewhere it was 3048 or something. Data collector. So data collector for sequence to sequence. So one input at the same time the output sequence one after another. Tokenizer is equals to tokenizer. Data number plots is equals to 2. Packing is equals to false. So you can make 5x faster for short sequences. Augment is equals to train arguments per device batch size is equals to 2. Gradient accumulation and the max steps. Number of epochs, number train epochs is equals to 1 if you want full train. Learning rate 2e minus 4. Not in B float 16 supported. BF 16, so B float 16 is supported here. And Adam weight optimizer 8-bit we are using. So this is done now. So it's loading this one. Seed is equals to 3407 and output directory is equals to outputs. You can see here we got the outputs folder created here. So right now the things are getting trained here. The responses. So this is Hugging Face trainer, and this is we also use Unsloth's train on completions method, and that's the one here. Okay, so the mapping is done. You can see you can compare. So using Hugging Face here, for this it took almost 3 minutes, and here it took just 53 seconds with Unsloth. Tokenizer.decode trainer.train data set. So it's decoding the input IDs. These all are the IDs. Space is equals to tokenizer, add special tokens is equals to false, input ID 0, tokenizer dot decode. So if x double equal to minus 100, else train with the label. So you can see here, astronomy. Okay, so now below this, we have the code to see how much memory has been used and to train. So let me retrain this. So previously I have terminated it due to some issues. The recording was stopped here. So now again I am retraining it. Let's here already the two steps are done. Only one epoch we have kept, means one iteration. So in one iteration only it should complete with the maximum of 30 steps. Let's see how it goes. So the first training accuracy is 54%. Okay. 57. So gradually there is an increase. Let's wait and see how much it goes on. So actually it was, yeah, 84. You can see. So it should get better accuracy going forward. Previously when I ran it gave 74. I guess now due to some mistakes I guess it's improving automatically. Let's wait for it. So I'll just pause till I complete this because it will take some time, approximately 3 to 4 minutes. So once the training is done, we'll continue the video. So yeah, it's done. So it took approximately 8 minutes. So training loss you all can see here. So it's done here. And let me to just run this code as well. So you can see here, show finally memory reserved, and 8 minutes 24 seconds is what it took for me to train this inferencing. So you can see from unsloth.chat template import get chat template, tokenizer is equals to get chat template tokenizer and Llama 3.1, and we have enabled it native 2x faster and to CUDA. So we are using CUDA only. So let me run this. You can see here, so the results are out. Fast language model or for inference model enables 2x native. So let's run this as well. Text streamer, we can use it. Saving and loading the fine-tuned model. So this is our next task. So let us save this model. So we can save these models as LoRa model. So LoRa model, tokenizer config JSON and special token map.json and tokenizer. So it's in that. So let's refresh this. So in LoRa models, you can see here all things are available here, and the README is also there. Model card and updates on it. So here you can just see here, now we are calling the model. Actually we are calling and we are giving a message. Describe the tallest tower in the capital of France. So you can see here might be Eiffel Tower, which is located in France, and you can see the Eiffel Tower was, and about this the global symbol of France and the details about the Eiffel Tower. So you can use the Hugging Face auto model as well for this if required. So you can just here this you got the output, right? So we have fine-tuned the model and you got the results here. So let's stop till there. You can even convert to GGUF. You can give a try on this here. Okay. And even you have the Olama notebook here if you want to try it on Olama locally. So you can give a try on this. If you want me to try it locally on my Jupyter notebook using Olama, definitely you can comment and I'll use this same notebook and I'll try to explain you all. Okay guys, so that's all for today's video. Do like, share and subscribe the channel. I hope the entire fine-tuning of Llama 3.1 was interesting. So you can give a try on it. This particular notebook link will be in the below description of a GitHub link I'll mention in the description. Okay, so meet you all in my next video. Bye bye.